Today we're going to talk about the power rule, the first of our shortcut type rules that we'll be working with for our derivatives over the next several weeks. To begin with the power rule, what I would like to do first is show you a little proof and the way it works out. Suppose we have a function which has some constant times x to the power of n. The definition of derivative, which we've used a lot now, would have us plug the x plus h in and set up our definition of derivative formula as follows. When I expand x plus h to the n, trust me on this, I'm going to end up with an x to the n, an n times x to the n minus 1 times h plus, and it just keeps going. The most important thing is that there's a c involved in every single one of them. And when I subtract the function at the end, my minus cx to the n, my limit will end up looking something like what we have on the screen right now. Only two pieces will cancel. As we've done, I'm going to factor in h out of everything that is still remaining. Everything will still have an h except for the n times x to the n minus 1. And of course, don't forget, as I did, the constant is still there. Let's look at this in real-life example. Suppose we want to find the derivative if f of x is equal to 5 times x squared. Well, essentially all we do is the 5 stays. The 2, the power, drops down, and then we subtract 1 from the power, giving us 10x. We'll take a look at a couple more of these. I'd ask you perhaps pause the video right now, try these, and then when you've given them a try, start up the video again. The first, bring down the power of 3 multiplied by the constant 3 gives me the 9. Bring down the power of negative 2 times the constant 4 gives me negative 8, and then I tidy it up. To do the second one, we expand it a little bit, and then we drop the powers and simplify. And the third one, something interesting happens. When I drop the 0 as a power, it ends up giving me 0. This is what we call the constant rule. If f of x is a constant, the derivative of that is always going to be 0. A few more examples. Suppose f of x is equal to 6x to the 4 minus 3x cubed minus 2x squared plus 7. I've got a second one. Actually, what I'm going to do is I'll put 4 of them up here total. Again, I'll ask you to pause the video as soon as the fourth is up and give them a try. The first f prime of x, I just, again, drop every single exponent into the front, multiply it by the constant, subtract 1 from the exponent. That's the shortcut. That's the way it works. For the third one here, I'm rewriting the x as inside a square root as x to the power of a half. It helps me to just write it out a little bit simpler. And for the fourth one, it makes sense to multiply these two things together, giving me all individual pieces which I can apply the power rule to for each of them. I know this moved fairly quickly. I would ask you to perhaps go back, review it again, just follow how every single time the power is dropping down, and then after the power drops down, it gets multiplied by the constant, and then we subtract 1 from the power. Here's some homework. Enjoy it. See you next day.